Today we're going to be learning about graphing rational functions using degree rules. Our objective is that we will be able to use degree rules to graph rational functions. So what's an asymptote? This is new vocabulary for us. It's an invisible line that the graph never crosses or touches. So our steps to graph rational functions when they're in a single term, which is what we'll be doing today. The first step is to find the vertical asymptote. We do this by factoring the denominator. Next, we're going to find the horizontal asymptotes. We'll be doing this by using the rules that you see below. These rules down here. Then we're going to find the x-intercepts by setting the numerator equal to 0 and solving. Then we find the y-intercepts by plugging in 0 for x. Next, we're going to plot everything from steps 1 through 4 and use Desmos to sketch. So for the horizontal asymptotes, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is automatically y equals 0. If the degree on the top is equal to the degree on the bottom, then y equals the leading coefficient of the top divided by the leading coefficient of the bottom. And if the degree on the numerator is greater than the degree on the denominator, there is no horizontal asymptote. And we actually won't be dealing with those at this time. You'll deal with those in a different class. All right, so our first example, h of x equals 6 over x minus 3 and x plus 4. So step 1 says we're going to find the vertical asymptotes by factoring the denominator. Our denominator is already factored, so we want to see what will make them equal to 0 because we can't divide by 0. So our first vertical asymptote would be at x equals 3 because 3 would make x minus 3 equal to 0. And our other will be at x equals negative 4 because that'll make this factor 0. For as far as our degree, our numerator does not have an x, so that would be like x to the 0 power. And on the bottom we have x times x, which would be x squared. So the numerator is less than the denominator, which is our first rule. So the horizontal asymptote is y equals 0. To find our x-intercept, we plug the set the numerator equal to 0 and solve. Well, 6 can't equal 0. That doesn't make sense. So there is none. There's not an x-intercept. For our y-intercept, we plug in 0 for our x's. Zero minus 3 is negative 3. 0 plus 4 is positive 4. Negative 3 times positive 4 is negative 12. 6 over negative 12 is negative 1/2. So our y-intercept is 0, negative 1/2. So let's plot these four things. All our asymptotes we're going to plot as dotted lines because they're technically invisible. So x equals 3, x equals negative 4, y equals 0, and then we don't have an x-intercept, which makes sense because there's an asymptote there. Our y-intercept is 0, negative 1/2. And then we're going to use Desmos to help us sketch the rest. So we're going to have y equals 6 over x minus 3 times x plus 4. So it's going to curve on the left. It's going to make sort of a U shape, upside down U in the middle, and then a curve on the right. So it goes something like that. U shape going through our negative 1, then a curve over here. For domain, you can write the domain the same way we were doing for solving and operations. So x such that x does not equal 3 or negative 4. If you wanted to do it in interval notation like we did earlier in the year, it would be negative infinity to negative 4, negative 4 to 3, and 3 to infinity. So typically using set notation is going to be a lot shorter. End behavior. As x goes to positive infinity, f of x goes to, and as x goes to negative infinity, f of x goes to. Remember that part never changes. So as x goes to positive infinity, so on the right, so as we move to the right, that curve is getting closer and closer to the asymptote here because it's never going to cross that. So it's getting closer and closer to 0. As x goes to negative infinity, so on the left, it's also getting closer and closer to that asymptote, so it's also going towards 0. All right, for our next one, vertical asymptotes. There's nothing to factor in our denominator, so it's whatever's going to make this 0, which would be 0. For horizontal asymptote, we have x to the first over x to the first. So that's our second rule, if the degrees are the same, so the leading coefficient of the top divided by the leading coefficient of the bottom. And since they're both 1x's, it would be y equals 1 over 1, which is just y equals 1. Our x-intercept, we're going to set the numerator equal to 0 and solve. So x equals 1, so our x-intercept is 1, 0. our y-intercept. There is none because our vertical asymptote is on the y-axis. So vertical is at x equals 0. Horizontal is at y equals 1. Our y-intercept is 1, 0. Let's go to Desmos to see what the rest looks like. So y equals x minus 1 over x. So it looks like that. So we have a curve going up on the left and then going down the right. So we know it goes something like that and like this. So for our domain, we know that x can't equal 0. So x such that x does not equal 0. And our range could be everything but where this asymptote is. So it would be y such that y does not equal 1. Our end behavior as x goes to positive infinity, f of x goes to, and as x goes to negative infinity, f of x goes to. So as the x's get more positive, it's going towards the asymptote at 1. And as the x's get more negative, it's also going towards the asymptote at 1. For our last example, we're going to see what happens when a factor cancels out. So when we factor our denominator, we get x minus 2 times x plus 2. Since we have an x plus 2 on the top, these factors would cancel out and would leave us with 1 over x minus 2. Since x plus 2 was the factor that canceled, whatever would make that factor 0 is the x value of our whole. And then we plug that into this function. So 1 over negative 2 minus 2 would be 1 over negative 4. So negative 1/4. Our vertical asymptotes, whatever will make our new denominator 0, which would be x equals 2. Our horizontal asymptote, our degree is greater on the denominator, so it's y equals 0. Our x-intercept would be none. Our y-intercept would be 0, negative 1/2. Domain would be x such that x does not equal 2. And our range would be y such that y does not equal 0. So vertical at x equals 2, horizontal at y equals 0. We're going to have a hole at negative 2, negative 1/4. So I'm going to draw an open circle there. Our y-intercept is 0, negative 1/2. And then we're going to put it in Desmos to see what happens to the rest of it. We're going to put in the original equation. So x plus 2 over x squared minus 4. And see how this pops up with negative 2 undefined? That's telling you that there's a hole there. And if you see my pointer, it changed to a hole. Whereas if I click anywhere else, it's a closed circle. But there, it's an open circle. So it's going to curve down and then be up in the right-hand corner. That's all for today. Fill in your summary, and I'll see you in class.